So did a little magic there, got rid of our little notes and where it comes from. Let's take a look at a model. Now, the model is going to be the same for each and every problem, which means this is definitely something we should memorize, especially on how to use it. We should be able to memorize this on how to use it. Hopefully you're taking a good look at it, because this is something the equation's not going to change at all. It's not going to change. So let's take a look at the model. You're going to have y equals A. A is going to be on the outside of the parentheses. So y equals A times. And then on the inside you have 1 plus your rate of interest divided by n. And then your exponents for this one is n and time. So let's define these variables. I would write this down because this is how the functions are, this is how the model is going to work. And so being that this is the model, like I said, it's going to work the same way every time, just depending on what these variables are. That's algebra. You got some variables, and then you apply the numbers to them, and that's how it's going to work every single time. So taking a look, A equals, A is going to be our principal amount. So if you know math, you already know what that means. Or if you know business, you already know what the principal amount means. Or, if you haven't looked at these words before, principal is just another word for initial amount or starting amount. So the initial amount, the starting amount for what you would start off with money-wise. So zooming in here on our equation. Other variables we need to know are, R is going to be our rate. Now here's the tricky thing with rates. Just want to say a word on them before maybe I try a problem out and show you. Rates are usually given to us as percentages, which means we have to do something tricky with that. So a rate of 6%, how would you write that as a number? Because this percent symbol means it's not technically a number we can use. So what's the number we can use that with? Hopefully you're thinking to yourself, 6%, decimals here, slide it over 2 to get 0.06. So that's the rate number that we want to use in our equation. Other variables then, n. N is going to be for the times it's compounded. So depending on our n value, this could be compounded once a year. The interest would be accumulated once per year. It could be accumulated monthly. Hopefully you're thinking monthly, 12 months, so 12 times a year. It could be compounded quarterly. Quarterly then, how many months? 3 months, 4 times per year would be quarterly. Or it could be continuously compounded each and every day. Hopefully you know how many days there are per year. 365. If you didn't know that, you might want to look at a calendar sometime soon. But, continuing on, t-value. T-value is generally going to be how many years are we getting this interest rate? How many years is it going to last? So generally the problem is going to give you the amount of years, the number of times per year that it's compounded, the R value, the rate value, and an initial amount. So let's take a look at an example and see exactly how are all these variables going to fit together. So let's erase some work here. Should have had enough time to write that down. Going once, twice, sold to the eraser. Believe it or not, this video is just like me in class. Who would have thunk it? It's like I'm here, but I'm not here. That's scary, huh? Should I start calling out people's names? Just kidding. I wouldn't do that. That's embarrassing. Unless I know you're not paying attention, which could be half of you. Just kidding. You always pay attention, right? Good, good, good. So, our model. Here's our model. Our Y value, our investment value, what we're ever going to get out of this. Y value equals A1 plus R over N, and then N to the T. So writing that down every time will probably help you. Let's start with a good example here. Let's say we're starting with $100. You worked hard. You know you're not going to use the money right away. You want to invest it in something. You made $100. Let's invest. So you looked around. You found a good rate. Pretty good rate these days. If you can get anywhere from 8 to 15%, you're doing pretty well. Let's say you found a rate for 10%. So 10%, the thing you want to look at though, is this a number I can use? Can I use 10%? Hopefully, you're thinking to yourself, no, I can't use 10%. Percent's like a label. So I'm going to circle that just so you hopefully remember that. Percent is a label. It's like saying I have 10 cents or I have 10 dogs. It's a label with that number, which means we can't use it unless the label's gone. So how do we get rid of a percent label? Hopefully you're thinking. Decimal is at the back of the number. Slide the decimal over 2 places to the left, which will give us a value of 0.1. This is the number. Yes, we can use it. So hopefully you thought to yourself, yes, I can use that number. Good. You got it situated. Hopefully you notice every time that's what you're going to need to do with your rate. So we have our starting value. We have our rate. Now let's use the number that's pretty much used with savings accounts. So N value, number of times that it's compounded per year, generally is going to be 12 months. Or a way that they might write that is that we get interest monthly. So N is going to be 12 in this case. So take a second, write that down, get this example down. So N is going to be 12. Let's say you want to use this for, let's say this is money you know that you're going to need right after college. So college-wise, we're sophomores, juniors, 3 more years till high school's done. Let's say we screwed around a little bit freshman year, 5 years of college. Let's say 8 years. That's the amount of time when we want to pull this money out to use it, is 8 years. Let's figure out exactly what kind of interest we can get if we let our money sit into this account for 8 years. And what you'll find is the value at the end is going to be your final answer. It's going to include everything. So let's plug these numbers into our model. Hopefully you wrote them down. Because I'm going to erase them. So I'll add them in here quick again. Rate change to 0.1. N equals 12. T equals 8. Let's plug them into our equation. So, step by step, $100, that's our A. 100 times everything in the middle. So 1 plus our rate, 0.1, over our n, so 0.1 over 12, 0.1 over 12, close parenthesis, and then our equation says n times t. So 12 times 8. Hopefully you're taking a look there. That makes sense. All we're doing is plugging it in according to the model. The numbers are always going to change. The model never changes. So this is something I think we should understand. We should be able to use pretty easily. Now we got to go to the calculator. I would go through step by step to make sure we don't type anything wrong. So let's go through it step by step. Numbers I would start with, I'd figure out with the calculator 0.1 divided by 12 and 12 times 8. I would write those two numbers in. So next line, 100 times 1. Let's see, did you get 0.1 divided by 12? I might actually have to find my calculator on this one. 0.1 divided by 12. I don't have it off the top of my head. Let's go grab a calculator. Grab yours while I grab mine. Hopefully that was enough time. Found mine in the form of my phone. So let's go 0.1 divided by 12. What value did you get? Hopefully you got something like decimal point 00. Let's go 00833. So that's what I got with my calculations. Check me. Could be wrong. Math teacher's not always right, believe it or not. Other number I asked you to calculate, 12 times 8, value of 96. So that would be our second line of work. First line, input all the numbers. Second line, do a few of the calculations we know how to do. This is something you should learn to do. You can't always just find the answer all in one step. Take your time. Go line by line. There's nothing wrong with doing that. It's going to, more often than not, lead you to the correct answer rather than trying to do it all at once. Next step then should hopefully be easy. Adding the decimals together. So 1 plus the decimals there, giving us the growth rate. Hopefully you notice this is a growth function. The 0.008 is just big enough to make it greater than 1. So what you need to do then is figure out, say log back into my calculator here, figure out what is the value for this growth rate that we can multiply by 100. So on your calculator, start with the decimal. So start with 1.0083. Type that in, 1.0083. Either hitting X or the Y button or the caret symbol. When you hit that, then you're typing in 96. Hit enter. Should give us some number. I came up with 2.2. Let's go 1. Something like that. Now, if you're good with your 100 values, what that does to a decimal, thinking, slides it over 2 spots, which means how much money did we make after 8 years? Now, it's the more money you put in, the more money you make, but not too bad. $221.11. So check my math out. $221.11. That's not too bad for 8 years of interest. Now, if you're thinking about it, the way it kind of works is if you're looking to really save up a lot of money and retire, you would keep putting money into the same fund. And so what that does is every time you put in money, you're increasing this $100 value. So it's not like $100 is all you can plug in. You can plug in a lot more money than that. And hopefully you notice that in some of your problems. So take a look, use this example to help you with numbers. Let's go with numbers. Oop, that's not a number sign. Numbers 7 to 10. So if you're taking a look at numbers 7 to 10, this example, this discussion on the insurance rates would be a great tool to help you. Now, the only numbers we looked at was what if you plugged in insurance rates to help you. Now, you can use this with debt numbers as well, and it's going to work about the same way. They're going to give you a rate, and what that does is that increases your number here, and what you would need to pay off then is, after each year or each month, you have to pay off the extra amount of money. So if we did this just for 1 year and figured out what the new total is, you'd have to pay the money that's greater than 100. So if it was a debt or a loan equation, you have to pay off whatever money is greater than 100. And so eventually what you do is you pay the interest, you gain up enough money to pay your debt back, and you can make payments on that principal, on that initial amount, so you get less interest. But this should help you with those problems. Like I said, if you have any questions while I'm not here, please email me. You may work in groups, you may listen to music, but like I said in the last video, Monday, these problems are due Monday. If I come around and see that you have no work, you are out of luck, my friend. I'm not exactly pleased with some of our work efforts the last couple of weeks. I think that's shown in your quiz and test scores. So, you know what you need to do to get this work done. I am not your babysitter. You are at the point in your learning career where you should understand that if a teacher gives you something to do, it's expected that you complete that and do it. And if you don't, well, I'm only left to take points away. So, please work on these. Please have a good amount of that work completed, ready to go for Monday. Thank you.